Um, so today we'll start off with, let's go over one like that, and we'll go with x squared minus 5x minus 10 equals 0. And I think the one we did last time was 3. So that would be x squared minus 5x plus blank is equal to 10 plus blank. Half of 5 is 5 halves. 5 halves, quantity squared is 25 fourths. And that's going to give you x minus 5 halves, quantity squared, is equal to 40 fourths plus 25 fourths. And that'll give you x minus 5 halves, quantity squared, is equal to 65 fourths. Now let's take that over to the next page. What was our y-intercept? Negative 10. Was it negative 10? I think it was. Okay, vertex. Give me the two forms of the vertex. First, the point would be what? 5 halves, comma, negative 65 fourths. And the intercept form, f of x is equal to x minus 5 halves, quantity squared, minus 65 fourths. So there's your three things there that you can get from what we got so far. And now what do we do? Take the opposite of both numbers and intercept form. That's what we do there. Now what do we do? It's not rhetorical. I'm asking y'all a question. What do we do? Solve for x, Hubert. That's right, class. Solve for x. Y'all done forgot this stuff? Okay, we're just not going to talk. Square root both sides. X minus 5 halves is equal to, what's the square root of 65? 8.1 here. That's right, class. Over 2. X is equal to positive or negative 8.1 plus 5 over 2. What's 8 plus 5? 13. And half of 13 is 6.55. So that's going to be negative, or the positive 6.55 is going to be 1x intercept. And negative 8.1 plus 5 is negative 3.1. So that'd be what? 1.55? Negative 1.55 is going to be the other x-intercept. Not worry too much about the math, because what will tell us if we're wrong? That's not rhetorical, I'm asking you. Not the answer, but the graph, the sketch. Okay? Because technically these are our answers. So, alright, so sketch that graph. Because I got to erase this so I can sketch it. And I'm not going to try to take all those over to the forward because it won't work. where's the personality of the class? What's his name? What's his name? Last name. Behavior, yeah. Where's he? Nobody shot him, I hope. Nobody ran over him. Mr. Lou, you didn't run over him, did you? Someone's talking like this, run over him. Okay, nobody's going to talk to me today. We're just going to be Dr. Goodbody's class. Is that what y'all want to be?
Sure.
You're going to hand out some papers for us to write questions in?
What did I say? Negative 6 is 6.5, 6.55, and what was the other one? Negative 1.55. So there's your 2x intercept if I copied that over correctly. 0, negative 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vertex is 1.5. 1.5 this way, and negative is what, 4 to the 65 to the 16. Negative 16 and 1/4. That's 10. 13, 14, 15, 11, 12, 13, 14, 15, 16. That's good enough for government work. And then negative 1.55. 1, 2, 3, 4, 5, 6, 7. Well, pretty much lines up, even if you don't use graph paper, it should line up. Of course, what's your domain? Oh, real numbers, Hubert. That's right. What's your range? Negative 65 force to what? 65 force to positive infinity. That's your range. Decreasing from negative infinity to 5 halves, and increasing from 5 halves to what? Positive infinity. Now that's what we did last week. We also went over some family graphs that you can't use quadratic, complete the square with, but if it's given to you, you should be able to sketch it. Sketch that one. After you sketch it, I want you to give me domain, range, increasing and decreasing value. How long should it take you to sketch it? Less than a minute. I'm going to give you the parent graph for it. Parent graph looks like a what? B. Now, Mr. Pruitt, is it studies or is it alcoholic? You can. I got one giggle out of y'all. Why y'all doing this to me? Y'all just don't like me or what? It's raining, so what? Okay, there's 3 or 4 things that you should be looking at. 1 is that guy. 2 is that guy. 3 that guy. And run out of colors. Dang old parade. That guy. Now, I've already told you what the parent graph. What tells you that this is the graph? For what? The absolute value. So I'll do that in red. This tells you this is the parent graph. those graphs that we went over last time. I divided the paper up into 8. Those are the family of graphs, parent graphs, whatever you call them. You should know them by heart. Okay, so this negative tells us that we've got this same graph, only it's going which way? So we're going to draw. Hold on a second. So take that same graph, of course, don't look like it, but you just use your imagination. And we're going to flip it around. That's real good. All Bush's fault. I don't know why it's acting like this, but it's a rotation point. I know. Anyway, you get the whole point. Okay, so we're going to take that. And there it is. Okay, so that's gone. The negative's gone. And we'll just take, I hope we don't mess it up when we do this. I don't know if this one's not going to work out right. Okay, now what? What is the 3, fellas? Makes it narrower. There we go. Okay, and that takes care of, and I'll just draw, well, now it's yellow. Okay? And the negative tells us it's going to move what?
To the right.
To the right 2 places. Going to move 2 places to the right. 1, 2. Things I do for y'all. And then this, and that's, I'll take this plain old mauve color. Oh, that looks like purple. There's the 2 places to the right. And then we're going to move down or up. How many places? 6. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And then that's going to be our gray color. And now that's your graph. Now, of course, you don't need the red graph. The red graph is just, let me get rid of it so we're not going to mess with it. Okay? Yes, sir.
So if 2 was on
Positive.
it
The only time it's negative, I mean it's opposite. Watch the video from last class. What was the last day of class? Huh? 4th. Watch the 4th video because that's when I went over this. Now, the reason it is, and I'm not going to go into it too much, is the application, the intercept form of all functions follows this. F of x is equal to a times whatever, the absolute value or parentheses. It's really supposed to be x minus h. In this case, it's absolute value plus k. Now, if we want a negative h right here, all we got to do is plug in what? Well, negative 2. If you plug in a negative 2 right here for h, what do you get? The positive 2. So all the negatives turn into what? Positive. All the positives turn into negative. That's fine. I don't show that because if I tried to show you this and then showed you that and said, okay, we're going to go to the right, half of you would go, huh? That's why I don't care. Now, if you were all mathematicians, and be going to books and be mathematicians, we would talk about that, but we're not talking about it. All right? And that's your final. The green would be A, B, C, or D on your homework or your test. I'd give you A, B, C, or D, and you would pick which one was closest to the thing. All right, let's try another. Domain. All real numbers, good. How long does it take you to figure that out? A couple of seconds. Why? Because all are going to be all real numbers except for rational and what? Radical function. Unless I say, okay, the domain is from negative 2 to positive 2. And it would go negative 2, and it would stop right here, and positive 2. Well, negative 2, positive 2. Let's just say right here. So this would not exist. It would just be this line right here. So, but we don't want to do that. Range.
Negative 6.
Good. Negative infinity to 6. Now, there's two types of students in here. One student's going negative infinity to 6. Okay, that's it. And the other student's going, wait a minute, why is it negative infinity to 6? You're not going by the y's, you're going by the x's. You're not listening to what I told you at the beginning. What I tell you at the beginning. Domain is what? What values? X values. What is range? Well, you can't figure out the range if you're looking at the X values. Okay? All right? Increasing. Here's our plane. And as I go from left to right, what is my plane doing? From negative infinity to, what is this, 2? To 2. What is it doing? It's increasing. And from 2 to infinity, what's it going to be doing? Decreasing. And that's how you do it. All right, let's go over one you haven't seen before. I think we went over a cubic function. Let's go over a rational function. Not rational. A rational. Yeah, rational. F of x is equal to, and I'm just going to be lenient on you. Let's go with just 1. I'll just put a 1 here. 1 over x plus 2 quantity squared minus 3. Okay. Which parent graph is it? The other B. Not vodka, but what? Volcano. Why is it the volcano? Because it falls in the 1 over what? X squared. 1 over x squared. What's 1 over x plus 2? What is the x plus 2 doing? It's being what? Squared. So that's technically 1 over something squared. Which one of your parent graphs has 1 over something squared? 1 over x squared. You got to know those parent graphs. If you don't know the parent graphs, you're going to have a hard time. tell me something about this 2. Not the little 2, not the exponent, but this 2. First of all, let's take our highlights. All right, that's positive. That's a 1. That's that. And that's that. Now, we do know that our graph is going to look like what? That guy right there. Let's see if we can do this. So there's your parent graph. Now mine's not perfect, and yours isn't going to be either. We're not graphing these things, we're sketching. So that's what it's going to look like. But what's going to happen? Well, the yellow tells us that it's positive or negative. Positive, so it's going to stay pretty much going upward. The 1 tells us that there's no compression, or there's no compression along the x-axis, or no stretching along the what? Y-axis. It just stays the way it is. The positive 2 that's connected to the x, that tells us horizontal shift of what? 2 to the left. Now, you got to remember, all these parent graphs focus around what? The origin. So that's what you're going to move. You're going to move 1, 2 to the left. So that means that this middle of this volcano is going to move 2, 1, 2. So if you have to, 1, draw you up. We're just going to use the yellow one, okay? I'm sorry. 1, 2. So your new axis, your new origin is right here. Okay, so there's that. The gray tells us to move what? Down how many? 3. Down 3. So that'd be 1, 2, 3. So technically your new origin is what? 2 to the left and what? 3 down. There's your new origin. And the yellow is what you would look for on the A, B, C, or D as far as your homework. Now let's talk about domain and range. Is the domain all real numbers on this one? No, it's not. Because it's a rational function. And I told you that that would be a problem. What can you not have in a rational function? 0 in the denominator, Hubert. That's right, class. So you set the denominator equal to what? X cannot equal what? -2. So that means that domain is all real numbers, except x cannot equal what? -2, Hubert. That's right. And that's why you have a vertical asymptote, and that's what that's called. Write it down. Vertical asymptote. I don't know if it's tote or tote. I always get that mixed up. Vertical asymptote. That means that your function cannot touch this number right here. Why? Because if you touch that number, you're plugging -2 into what? This, and what do you get? And it blows up. Can't do it. Can't have your cake in what? Can't have your cake in -2. All right, in this section, there's going to be numbers that you can't use. If you can't use it, you can't use it, period. So therefore, you have to show it on the graph. And this dotted line is basically saying that you can go right up to me, but you can't, I ain't going to say you can't touch this, but you cannot touch me, all right? So the range is going to be affected also, isn't it? Because of the domain effect. And looking at the graph, you're going to get an undefined function at x is equal to -2. Well, if you plug -2 into this thing, you're going to get some befuzzlement here, -3, and there it is, -3. -3 is your horizontal asymptote. Okay? The horizontal asymptote. Tell me what the increasing values are. Increasing is from -infinity to -2. Do we touch -2? So it gets a parenthesis. Decreasing from -2 to what? You have to. Here's your plane. Plane's taking off. What's it doing? All right, going down the runway. What's it going to start doing? It's going to start flying, isn't it? Well, that's increasing. Put the plane right here. What's that plane doing as it's coming this way? What's it doing? Decreasing. So from -infinity to 0, I'm sorry, -2. -infinity to -2 is what? Increasing. From 2 to infinity is what? Decreasing. As long as you can do what we're doing on these last couple of 2 problems, you can do all of chapter 2. All of it. And then chapter 3, they're going to give you the problems that we've already done, and you can do the squares. So we're just going to go ahead and do all of them, and I'm just going to give you 2 tests at one time. Okay? Unless you want to take one separate. We're going to spend so much time on this, it really doesn't matter. Okay? Let's do a nerd. Let's do f of x. I'm going to let y'all do this one. F of x is equal to negative parentheses 1 over x minus 4 plus 7. I'll do that one. Now, some of your parent graphs, you may want to put the negative in your sketches also, because some of them can be a little bit confusing. Always go back to your B1 divided by parentheses x close parentheses, and I'll make the next one dark, and that'd be negative parentheses 1 divided by x close parentheses. There's that graph, and then the other one is you basically turn it this way. Now, some of you might have thought, okay, well, you flip this over. No, the best thing for you to do is to draw a picture of the negative if you don't know it. Another one that I would draw a picture of if I was you is y is equal to the square root of x. So x to the 0.5 and then negative x to the 0.5. And yes, x to the negative 0.5 is the square root of x. Even though I have to tell college students that, I don't know why. They should have learned that in algebra. Algebra 1 and 2, they should have told you that. And anytime you raise something to the 1/2 power, that's the same thing as the square root. But I find people who don't know that, and there's nothing wrong with it. Just okay, you got to put negative around the. Okay. Yeah, you got to put. Hold on. Yeah. Plus, you might want to put. Where's the delete? There it is. Okay, you might want to put parentheses around this guy too, because the calculator, believe it or not, some people that carry it to the bathroom and name them, they do not know everything. Okay. You don't want to grow up and be those people that can't make change. Okay. Always remember a sideways parabola. Okay? A sideways parabola makes up x squared, square root of x, and the negative square root of x. Okay? Just something that you might want to remember, because those two are the aggravating ones as far as the negatives go. Y'all come up with some weird graphs of the negatives of those two. Alright? So let's go back to the problem at hand, and that's this guy. Now we know that the parent graph says there's the parent graph. I'm going to copy it before I do everything else, in case I need it. All right. You'll get the point. Okay? That's that one. And this negative, we just said that basically it turns it what? Turns it this way, doesn't it? So it's not going to let me turn it. I don't think it'll. Kind of like that right there. Okay, well that's going to screw up now. I'm not going to be able to not. We'll just do this. We'll just turn it this way. There we go. Dang on more than one way to skin a what? You skin a cat? Good. You don't know what I'm talking about. It's your parents' fault. And bushes. So now we've just turned it around. So that's done. We just did that. And now this 4 tells us we're going to move it which way? 4 to the right. And of course, it's not going to let us. You know, so this is what I'll do. I'll just draw with a red line or a blue line. 1, 2, 3, 4. There's our vertical asymptote. Or that's our vertical asymptote. 4. And then what does this tell us? 7 up. 1, 2, 3, 4, 5, 6, 7. So now we're going to take this guy and put him where? I'll just draw it. He'll go right here. Like that. Y'all ought to appreciate me. I'm doing the best I can. And the other one, and that's what it looks like. So, what's your domain? All numbers except for 4. So, all numbers except for 4. So, that's your domain. Range, negative infinity to what? 7, and then from 7 to infinity. Be careful, this may be a union or an intersection. I don't really care about that, but all I care about is that you get these parentheses right and get the numbers right.
How's it going to take it with my lines? Is it going to want you to do the union?
Yeah, I'll have a union. It's not an intersection, because intersection will be overlap. Here, there's no overlap. You start here, you go to here. Do you overlap with this guy? No. So it's not an intersection. So don't do the intersection. Anything with intersection, it's not the answer. This is what they'll have. They'll have this with a U. That's what you do. And the increasing from negative infinity to 4, from 4 to what? That's increasing in this limit. They're both increasing, aren't they?
Yeah.
Both increasing. So it'll be increasing from negative infinity to 4 and increasing from 4 to infinity. I don't know if they cover vertical asymptotes. We're going to talk about that a little bit. Somebody tell me if they cover vertical asymptotes in chapter 2. I believe they do. Like 2.6 or 2.5. I'll just go ahead and go over. Somebody look up how you spell it. Asymptotes. I don't know if it's totes or totes. I never have. I can't remember. Don't say nothing, because some of y'all think it's so necessary. You didn't school before I get
Hey,
Huh?
you're a math major, though.
No, hey. Necessary, I can't even spell necessary. I want to put 2 C's and 2 S's. I don't know if I'm not. All right, whatever it is, asymptotes with a P or totes, it's the same thing. All right, vertical asymptote. Set, radical, or radicand, or what? Denominator equal to what? 0. And that's how you find the vertical asymptote. Now, in some problems, you'll be able to factor before you can set equal. I did spell it right. In fact, it's totes, like the old umbrella. Totes. Asymptote. Some people know like tote water. To carry. I don't know where tote comes from. I have to look up the origin of tote. I just wonder if some redneck in South Carolina came up with that word, or did it have some kind of origin to Latin origin? Tote. 2, sometimes you will have to factor then set equal to 0. Example, x plus x squared plus 4x plus 4 over x plus 2 to the third power. Alright, now if you use the first rule, you set the denominator equal to negative, or to, when you get negative 2, set it equal to 0, you get negative 2. But you can't do that yet. The reason you can't do it yet is it's not in the simplest what? Form. So in order to set the radicand or denominator equal to 0, you have to have it in simplest what? I don't think that's right. Form. So that means I've got to factor the top and see if anything will what? Cancel. X plus 2, 1 squared, over x plus 2 to the third power, and what happens? These two will cancel with these two and leave x plus 2 what? Now you can set equal to 0. Now, of course, it's still x minus 2. But it's not always going to be the same answer. Because sometimes you're going to factor this. Like this will be a trinomial, and you're going to factor this. So you can't set it equal to 0 because you need to find out if anything cancels. When you see a graph and you see an open circle, on a graph, open circle, when you see an open circle on a graph like this, when you see an open circle right there like that, that means that there is some factoring. That means that there is some factoring going on with the problem. And then after you do that, after you see the circle, you see a vertical what? Asymptote, like right here. And you've got a circle, an open circle and a vertical asymptote. That means that the circle goes with the pre-factoring. Circle goes with the pre-factor. And then the vertical asymptote goes with the what? Simplest form. So you might want to write that down for later. Because some of you may be doing homework and you'll be doing a problem, and the problem starts off with x minus 2 in the denominator, or I don't know, I can't find it, we'll find an example. And you go, okay, vertical asymptote's 2. And then you get the answer, and the answer has a circle at negative 2, and then it has a vertical asymptote at 5, or whatever the case may be. And that's because that the open circle goes with the non-factored, and the vertical asymptote goes with the simplest form. And this may not be equal to this. And we'll get to examples of that. So just make sure you understand that when you find vertical asymptote, you're going to set the radicand or the denominator equal to 0. But make sure that when you're dealing with the denominator, that it's in the simplest form before you set equal. Try to think of it. Horizontal asymptote. Now this is in your book somewhere. There is a, and if somebody has their book handy, look for that page. I don't see anybody with a book, but oh well. I don't know. It's where it says horizontal asymptotes. Look in 2.5, 2.4, somewhere in there. look for horizontal asymptotes. And you've got three conditions. And the three conditions are based on the degree of the denominator and the degree of the numerator. Let me find it. Let's see if I can find it. It may not. It may be. I'm looking forward, but I don't see it. So I need a table of contents. Dang old search. Dang old horizontal. Totes. Ah, spelled it wrong. I'm forgetting something. It should be a Y in there. Dang old Y. Okay, it's chapter 4. Probably. That's not the page I'm looking for, but there's a page, so it's in chapter 4. We don't have to worry about it. But I would like to find it so you'd have it. So I'm going to find it right quick, so just bear with me. It's probably in that section. Just give me a second. Okay, well, I don't know where it is. Yeah, it may be in chapter 3. I don't know. I don't think it's in chapter 3. Huh? I didn't hear you. Horizontal asymptotes. Okay, 4.2. There it is, page 279, right there. So you need to make a note on page 279, and I'm just going over it. We're going to go over it again, right here, 279. So make a note of it. And it says right here, if the numerator has a lesser degree than the denominator. So I'm going to go over here. If the numerator has a lesser degree, numerator has a lesser degree, and I'm going to go denominator degree minus 1. Alright? If the numerator has a lesser degree than the denominator, I'll give you an example. X squared over, or x over x squared. Is that a lesser degree? Yes. The degree of the numerator is the first degree. The degree of the denominator is what? Second degree, thank you, class. Then you go with the coefficients. In this case, the coefficient is 1, or let's say 0. I'm sorry, 0. I got it mixed up. Should be 0. Where's the 0? Yeah, it is 0 for the denominator, but not the numerator. Yeah, equal to 0. Line is x is equal to a is the vertical asymptote. Alright, so and find any vertical asymptote by setting the denominator. Oh, I did that one. I'm talking about here. Here we go. If the numerator has lesser degree than the denominator, then the horizontal asymptote is 0. So on that, coefficient is 0. I've got that mixed up with the second one. It's much easier to do this when you got an example. So if you was to draw this, you know the vertical asymptote, the horizontal asymptote would be the actual what? the what? When the horizontal asymptote is 0, that's the x-axis. Now, what about when the degree of the numerator is the same as the degree of the denominator? When the degree of the numerator and the degree of the denominator is the same, meaning d and d, in other words, 2x squared over x squared, then you go with the coefficients. So the horizontal asymptote here is equal to 2. So that one would be 1, 2. So your horizontal asymptote would be x is equal to 2, or y is equal to 2. And then the last one is the one y'all really love. And we won't do it, but the one y'all really love is if the degree of the numerator is higher than the degree of the denominator. And what do you do then? Think of y'all's favorite subject. Long, what? Division. You divide. And we'll do that in chapter 4. All right, let's get back to what we were doing. So let's say you understand all of your bandwidth graphs. You should be able to do those now. Let's get back to the quadratic. Let's move up. We've done a 5, we've done a 3, and we've done the Mickey Mouse x squared plus 4x plus 4, the easy ones. We did those, 1 and 2. Let's move up to 3. What would 3 be? F of x. No, we can do the 0 later. What's wrong with this one? That's not rhetorical, I'm asking y'all. It's got a negative in front of the what? In front of the x squared. You can't do complete the square with a negative right there. So what do? Erase it? Yeah. Erase it. Move on to the next problem. Just move through it. I don't understand why you erased the negative. Okay. Did I do that? Yes. All right. So remember, you can't do. You can't do completing the square with negative a. Okay? Can't do it. And we're going to draw a little arrow or an arrow, depending on where you're from. Right there. And we're going to take a red marker and we're going to draw a negative right there. So you put cannot be done and you go to the next problem, right? Nothing is that easy. Okay? So what do? Well, first of all, you move to C like you always do. So take your handy dandy black marker. Set equal to 0, negative x squared plus 2x minus 7 is equal to 0. Setting y is equal to 0 so I can get my x-intercepts. Move C, negative x squared plus 2x plus blank is equal to 7 plus blank. I'm going to paint that one red again, because we're stuck on this thing right there. That negative is causing a problem. So we've got to factor it out. Now, in order to factor it out, we've got to remember a rule. whatever you factor out, you have to multiply right side blank by that number. Okay? Now write that rule, and I want you to highlight it. I want you to put a cloud around it. I want you to put stars around it. I don't care. I want you to paint it red, because what you're going to do is you're going to forget to do that on the test. So what do I need to factor out? What's in front of this x squared? Is it just a negative by itself? It's a negative 1. So you got to factor out a negative 1, and you got to multiply negative 1 by that right-hand side of it. Now this is where I need to tell you. Just trust me. Alright? Because I can show you why. But I would have to go back to the complete the square completely on the left-hand side of the equal sign, which I don't show y'all because it's confusing. So if you want me to confuse you, then really confuse you, then we'll do that. But I don't want to do that. So I'm going to factor out the negative 1. I'm going to do it in red. So negative 1, and then parentheses. Now I'm just showing these parentheses. You don't have to write parentheses around these two, but I'm just showing you. So I'm going to make this one and this one. I'm going to make them dotted, meaning that you don't have to put them around these two numbers right here. And what will that make this? What's negative x squared divided by negative 1? And there's our nice positive x squared that we need. And what's 2x divided by negative 1? And then plus blank is equal to 7 plus, hold on a minute, plus negative 1 times blank. Okay, whatever you factor out here, you've got to multiply by this right-hand side blank. And that's what y'all going to forget. Y'all going to be coming up here. You're going to be saying, Hubert, I did this problem 5 times. And you send it to me, and I go over it, and I will do it. And I'll say, multiply this negative 1 times blank, and you'll go, dang it! Because you forgot to do it. Yes, sir.
You don't do the whole right side,
Just that. Don't ask why. I know you want to. But it all goes back. And if you look in your book in chapter 2 or 3, chapter 3, we're in chapter 3. If you go back in there, you'll see that they teach you how to do all of this on the left-hand side. And when you do it on the left-hand side, you multiply this negative times whatever's here and here. And that's why you do it. It's because it comes from another version of complete square. And you can look in your book. I'll show you where it is when we get to it, but I'm just going to show you. I'm not going to do it. All right. So now we can do what here? Complete the square. We can complete the square now. I'm going to take this over to the next page because I don't want to do it right here because it's too. Now, another thing that y'all are going to forget to do. Y'all going to factor that negative 1 out, or you'll try to do complete the square before you factor out the negative 1. All right. Go back to this page. I want you everybody to make a note on your notes. This today is the 9th of February 2015 datum, because when we get to this and y'all give me a homework problem and you say, I went over this problem 5 or 6 times and I don't understand what I'm doing wrong, I'm going to go through the problem and Miss Anderson, she's going to say, well, I thought we were supposed to complete the square first. And I'm going to say, go to your notes on whatever the day is, and y'all going to go back to those notes, and it says right here, before I can complete the square, right here, You can't complete the square with a negative out front. So you tried to do that. You've been foreseeing this because that's what's going to happen. All right, so let's take our handy dandy next page. All right, I'm going to rewrite this, and I'm going to rewrite it in black now. -1 x squared minus 2x plus blank is equal to -7 plus -1 times blank. Now you're ready to complete the square with this in the parentheses. What's half of 2? 2 divided by 2 is 1. 1 squared is 1. So 1 goes here and there. And that gives us shortcut number 2, which it either gives number 1 or number 2 based on what that is right there. And that's going to give us -1 times x minus 1 quantity squared is equal to, what's -7 minus 1? And now you're ready to finish it. So finish it. What's our vertex? 1 and 8. Divide by -1 on both sides, and that's x minus 1. Quantity squared is equal to 8. Take the square root of both sides. X minus 1 is equal to positive or negative what? 2.9. X is equal to positive or negative 2.9 plus 1. That gives us a 3.9 and a what? Negative 1.9. What's our x-intercept? What was our, begin with, -7? That's our y-intercept. All right, y'all look and see if it lines up. Now remember, which way is this parabola going?
Down.
Open and downward. Why? Because the one is what? Negative, so that tells you that it's opening downward. So that may make a difference when you're trying to line the points up. Don't try to line them up opening upward. Guess what? It'll never happen. I'll finish you. I can't get it to work. You're sitting there trying to do it like this. Going down, going down. If you put it in its intercept form, f of x is equal to negative 1 x minus 1 quantity squared plus what? It's opening downward, goes to the right one place, goes up one place, and it is a regular parabola because of the 1. Y'all have to tell me everything because I'm not going to write all that down. Our y-intercept is 0 what? 7? Huh? Hold on. Oh, negative 7. 0, negative 7. There it is. So it's negative 7. Would I have caught that? Drawing my drawing? Yeah. You wouldn't have been able to get it to work. What was our x-intercept? Okay, 3.9 is 4. 1, 2, 3, 4. And negative what? 1.9? Negative 2.
Yeah, I'm confused. If it's opening downward.
We've got something wrong. Let me go back. We got something wrong.
Why, whenever you, up there, we had the negative 7 on that side,
Yeah.
do you change that?
No, you do if you just are on a distant planet somewhere. That negative 7 is supposed to be positive. I have no idea why I changed it to a negative. Sorry. I think it's the end of the day. Thank you. Okay, so that would be, y'all help me out. 7
That'd be 6.
plus, that'd be a 6 right here. But like I say, the drawing will help you every single time. Alright? So that's going to be the square root, that'll be a 6 here. Be a negative 6. And this will be a 6. Square root of 6, so let me go over here. Square root of 6 is between the square root of 4 and the square root of 9. Square root of 4 is 2. Square root of 9 is 3. 4 to 9 is 5. Half of 5 is 2.5, so the square root of 6.5, square root of 6.5 is 2.5, so the square root of 6 would be, what, 2.4? You know, check it in your calculator since it knows all. So that's going to be positive or negative 2.4. .4 plus 1 is 3.4. And negative 2.4 plus 1 is negative 1.4. Still don't look good. Yes?
In that bottom part with negative 1 x subtracting 6, where is that negative 1 coming from? Not the one outside of
Right here?
up 1. Yes.
Right there? Shortcut number 2.
Oh, okay.
What's the vertex? Let's do the vertex. vertex is what? 1 and 6, positive 6, is that the vertex? Make sure I didn't do it wrong. Yeah, 1, negative 1, 1, and negative 6, and negative 6. No, you do the opposite, and it'll be positive 6, that'd be positive 6, sorry. So negative 1 will be positive, okay. So 1 and 6, so 1 and 6, 1, 2, 3, 4, 5, 6.
Why would it be?
Some ain't right.
Why would it be a negative 6?
Well,
Because once you divide, when you divide
if it was negative 6, then you'd have no x-intercepts.
well, there's no way it's going to.
Yes, it's not working. Something's not working. So, what time is it?
3:55.
Hold on, what's the problem again? Negative x squared
Plus 2x minus 7.
2x minus 7 is equal to 0. Negative x squared plus 2x plus 1 is equal to 7 plus 1. Negative the x squared minus 2x plus blank is equal to 7 plus negative 1 times 1. Half 2 is 1. 1 squared is 1. 1 negative the x minus 1 times the squared is equal to 7 minus 1. Negative x minus 1 times squared is equal to 6. So that's going to be negative, be a positive 1 and a what? Negative 6. Okay? And 0, negative 7. And then, there we go. Here it is. No x-intercepts. Right here. Because I had a negative 8 there before. If you divide by negative 1 on both sides, what does that give you here? X minus 1 quantity squared is equal to negative 6, and you can't do what? You can't take the square root of the negative, which that's what we're going to get into with no x-intercepts. So, it's this. 1 negative, positive 1 negative 6, and 0 negative 7. So it looks like that. We'll go over it again.
Can you leave it up for a second?
Yeah, I'm gonna leave it up. Let me get the roll right quick, and then y'all can skedaddle. Somebody hit my button for me, please. One on the back top. Yeah, make sure it cuts off the little blue. Did it cut it off? Yeah. Yeah, I have no idea, but yeah. You work at Target. You should know these things.
I'm gonna have to leave for work.
Go ahead, I got you.
Okay.
Sorry about keeping y'all so late. I usually don't have you this late. I'm sorry.
We're 1 minute over.
I know, but some people go into cardiac arrest. That's not what I want. Faculty. Attendance. Shut that off.